Squeaky chair. Come on, you're being slow today, Twitch. There we are, now we're live. Alright, so we're going to continue with our ProcJam. We're going to make it so that when you play cities, it knows what kind of uses they have in addition to where they are. And we may do some pixel art, I don't know yet. There's going to be some music in the background today through no fault of my own. My neighbors are blasting some really old sounding Spanish language pop music. So if you hear that thumping through my roof, make sure to dance along and get your exercise. Also, I don't think it's going to cause any problems where I get muted by Twitch, but if it does, it does. That's all I can do about it. Sounds like it's far too old to actually be on YouTube's radar, though, or Twitch's radar. Anyway, now that we're running, let's go ahead and tell the world. Streaming cities on planets. Indie dev, ProcJam, paste. And we'll pop on over to here. No, not there. There. And now we'll go over to Twitter. All right, sounds like they have started on a different ancient Spanish language pop song. But whatever works for them. I have -1 viewers. That is something. Congratulations, you are my -1th viewer. Or you were the 0th viewer and you left. I don't know. So what I've got here is a setup where we have this planet that gets properly processed. Hold on, I forgot to tell it to get properly processed. Yoink. We've got this planet that gets properly processed, and we can already place cities on it. What we need to do is have it so that when we place the cities, they have stats. And so to do that, we're going to need to calculate out a bunch of random things. So, for example, if I start up with a city right here, I need it to know what that city is good at. And similarly, if it's over here, I need it to know what that city's good at, and that city's good at. And that's going to be a combination of factors. The first factor is going to be the colors of the land that it's on. And this may vary by, planet type to planet type. I haven't decided yet, but we'll hard code it for now, and then later on we'll make it so that it's planet type by planet type. So we're going to just go ahead and have public, we have a protected int num tiles, and a protected color 32 array. I guess we just want an array of colors, do we? We may just want a list of colors. So we don't need num tiles if we're going to do that. Albedo equals new list. And then we're also going to need to be able to calculate those colors into a couple of stats. But I don't know what those stats are just yet. So we're going to go ahead and just, for the moment, make a dictionary string int, or maybe string float. Now, this won't show up anywhere because Unity does not know how to display it, but it will allow us to access it in code, and that's good enough for me. And now I'm getting real sneezy all of a sudden. I don't know why. For some reason, starting up a stream makes me sneeze. So here we're going to go ahead and say public void mark color, I guess. And we're going to just take a color 32 color. And what we're going to need to do for this is translate this color into a resource. So for that, we're going to need to do some calculations to determine what kind of color it is. So what resource a color stands for is fairly complicated. And what we're going to need to do is we're going to say that the color is we're going to translate it into a vector 3 that's RGB. Just because that's a little bit easier for me. So we'll do a vector 3 C equals new vector 3. We'll make this a color like this. The reason we'll translate it back over into this is because that way the color.x, y, and RGB is going to be between 0 and 1 rather than 0 and 255. So just to check that, we're going to say if c.magnitude is greater than 3, then debug.log error colors did not convert into 0, 1 bounds. And if that's ever true, then all the colors are suspect, but that should be okay for now. So once we've marked the color, what we're going to want to do is determine what the color is. And the one color that's easiest to check is that we're going to check it against just a 1, 1, 1, because a 1, 1, 1 is bright white, and that's going to be ice. So the magnitude of a 1, 1, 1 is not actually 3. We'll just go ahead and compare it. So we'll say if c.magnitude is greater than or equal to vector 3.1.magnitude times 0.95, then we're going to say white is ice. Debug.log or string resource equals resource equals ice. And down here we'll say debug.log resource discovered, and then resource. So what we're going to want to do is just have a big old set of if statements, basically, which check for various kinds of colors. So a big one aside from this is going to be blue. And there are two basic categories of blue. There's very, very bright blue and very, very dark blue. So there's going to be one that is mostly blue, and then there's going to be one that is blue plus other stuff. So we're going to say if c.z. Actually, why am I doing this? Let's just convert it over into a color. We can just go ahead and fat finger. We can do it either way, so it's fine. If color.b is greater than 0. Let's see, 0.6 water. If color.b is greater than if c.magnitude is greater than 0.75 bright water, resource equals, well, this bright water is, we're just going to make it water because it looks good. Else we're going to go ahead and call it dark water, which is not, we're not going to say that it's resource equals dark water. We're going to come up with something else that's going to be. We'll call it like polluted water. Sludge. We'll call it sludge. So this basic thing here is that we're checking for water. What we're going to do is we're going to check for all the various things it could be. Green is a particularly vibrant suggestion, but since green often blends with blue, we need to check for blue first, and then we can check for green. I've forgotten else. Else, if color.g is greater than 0.6. So here's the thing. There are cases where blue is actually going to be greater, but it's not going to be the greatest. So we're going to actually want to have a color comparison. So public void, a public float, what do you want to call it? Prominence. Color, int slot. Oh no, wait, well, we'll go ahead and just make it a int. It'll return an int. So what this will do is we'll just return which one of the colors is dominant, if any. So if color dot r is greater than color dot g and color.r is greater than well, sorry, I'm just thinking through how to do this, and it's a little bit challenging to figure out. We're going to go ahead and create an enum to make this a little bit faster or a little bit easier. Enum prominent color. We're going to go ahead and have a black and a white, but we're also going to have a red, green, blue, and then we're going to have some of the colors in between, like gold and purple. But we also need to have fire for reasons that we'll get to later, and we may add more, who knows. And what we're going to do is we're going to go ahead and check for each of these. And in order to do that, we're going to need to have a way to check and see whether or not a given value is the highest value, and if so, by how much. So we're going to go ahead and say is highest value. And so here we'll say if check is greater than color.r, greater than or equal to color.r, and check is greater than or equal to color.g, and check is greater than or equal to color.b, then return true. Otherwise, we'll just return that. And then we'll also have a public bool is dominant value, where we're going to do the same check, but for it being substantially higher than the others, i.e. red rather than a light red. So for this, we're going to go ahead and do the same basic thing, but our if statements are going to be a little bit more complicated. So we're going to need to check and see whether or not red, whether or not we're greater than, whether or not we can be equal to red, or we can be significantly greater than red. Like that. And we're going to do that for each of the three colors. There we are. And that should get us the two values that we need. So what we're going to do is first we'll check, we don't need this anymore. First we're going to go ahead and check whether or not it's ice. So we'll go ahead and say if is dominant value 1. So we're checking and seeing if there is a dominant value. If there is no dominant value, if everything is at 1, then we are going to be, if everything is near 1, then we're going to say it's ice. So otherwise, we're going to check and see if it's water. So we're going to go ahead and say else if is highest value color.b. And then we'll check and see whether or not the magnitudes are true. So if is dominant value color.b, except for that's actually wrong. There we are. So there, now we can check and see whether or not it's dominant rather than if it's just greater than a number. Else if is the highest value color.g, greenery, resource equals greenery. If it's not blue and it's not green, then it's probably red. So else if is highest value color.r, red. This could be either red, or it could be gold. So if is dominant value color.r, resource equals rock or something similar. We'll go ahead and make this resource equals minerals. Else resource equals, and we'll go ahead and have that be something gold. Let's make a sand. So that should get us some colors. The only thing I don't like is this color.g, and that's because there are cases, actually lots of things I don't like. One thing here is we're going to have to check and see whether or not if color.r is less than, I forgot some parentheses. If color.r is less than 0.5f, then we're going to want to make that be something that's very, very dark and torn up. We'll call it, we'll call this mineral, and we'll call this sand, and we'll call this regolith. Just for now. Later on we may change it. But I did create this prominent color nonsense that I don't need anymore, so we're just going to delete that. All right, so that should be able to tell us what colors we're dealing with here, and so what we're going to want to do is add that to the dictionary if we don't have it. So if dictionary, if, what is it called, resources? If resources.key exists, resource, so if there is no key for it, create the key, resources.add, resource, comma 0. Otherwise, oh, either way, resource dot add, resource plus equals 1. There we go. And that should give us a list of all of our resources. And I think that it's not necessary to store the albedos because we're calculating them on the fly like this. So that should be fine. The only thing we need to check is the total values, but we can do that later on. So what we need to do now is make sure that that gets called, and that's going to be here in compare coordinate. So when we have this compare coordinate, we're going to need to just pass it down into mark color. Or maybe it's better in set ray. Yeah, I think it's probably better here in set ray. No, we always do compare coordinate. Let's go ahead and do compare coordinate. Changing my mind left and right here. So we do in fact get this albedo, and then we pass it off down to mark color. In fact, we don't need to have albedo as its own thing. Just pass it like that. Perfect. So now we should have that all set up. The last thing that we need to do is print out all of the values just for debugging purposes. And we're going to do that here under run. When we set calculate results, this here happens, and then we're going to go ahead and do a for each key value pair string float key in resources. Debug.log key plus resource key, so it's key dot value. All right, so let's go ahead and see whether this works. Got some sort of any bugs popping up here? Yes, there's at least one. Return. Oh, look at all that value. I forgot to pass it the colors. Any more bugs? Nope. Okay. Hit play and let's give it a shot. It's odd. This is not a very popular stream for me. Strangely, I had much more luck just streaming at random times. This is actually the time of day, the time of week I usually stream my real game dev. But it's the time of day when nobody is here, apparently. Hilarious. So if we take a look, we discovered this tremendous amount of sludge, and it says we got 90 sludge and 1 mineral, and we're in a crater, right? So that's pretty great. Let's go ahead and take this out, just because it's going to be in the way, and try one more time here. I think he has started to play I believe it is 90s Spanish rap. It's not very good, in my mind. I don't much care for it. I don't think I'd care for it even if I did understand what it was. Maybe that's just because it's thumping through my ceiling all the time. So let's go ahead and get some sludge. Sludge! So here you can see we've got 84 sludge and 1 water. Now in truth what we're going to have is a percentage. We're not going to have a total. because there's no reason for us to have a bigger city be better necessarily. We may have some kind of weighting system there, but the idea is that you want to try and pick where your cities go, and that's the most important thing you can do. So here you can see that we've got 22 vegetation in 1 water, 30 vegetation in 1 water. Here we've got a bunch of regolith, and that's it, just regolith. Now if we were to select this Earth-like planet and hit randomize, we can get a different planet. Notice that this one has bright water. There are 2 kinds of water, as I mentioned before. We were getting, I believe, sludge last time. Yeah, this one will actually be getting proper water, I think. Yeah, water. We actually got some sludge as well, and some vegetation. Interesting. If we click here, we'll get mostly vegetation, I think. And then if we were to spin this guy, you can see there's actually some land masses and stuff, and we can click down here, get ourselves some nice vegetation. I see what the problem is. So the problem is that this isn't being cleared between runnings. This is not a new city class not a new city object every time it gets run. It's fresh calculations, but it doesn't actually clear out the things that need to be cleared. So up here we're going to go ahead and say resources.clear. That way we won't get confused by the way that it has different amounts of, it just continually increases the amount of water we've got or whatever. Boom, boom, boom. All right, so if we click, that's all vegetation on a ridge, and then this should be all regolith on a ridge. Regolith in a crater. Okay, that's fine. And then here, regolith on a ridge. Regolith in a crater. Interesting. This is the hillside. Not getting very much performance out of these cities, but that's not too bad. So I do want it to be weighted by the amount of tiles that are in the city. So to do that, we're going to want to keep track of the number of tiles. Now we can do that in a couple of ways, but the easiest way is that since our resources are all having +1, we'll just go ahead and count up the total number of resources. Float total resources equals 0. By the way, if anybody has said anything, I haven't seen anything. I don't think you have, but just in case you're wondering. So what we're going to need to do here is determine the best resources in the long run. But in the short run, what we're going to want to do is divvy up the resources. So right now, our total resources is a value where if we divide everything up by the total resources, we will end up with an amount of total resources that always adds up to 1. That's not exactly what we want to do. What we would like to do is, if you have a large city, we would like you to have more resources. And if you've got a small city, we'd like you to have less. So to reflect that, what we're going to need to do is divide this by a different value, not by total resources. If we divide it by the square root of total resources, then that will mean that the larger you get, the smaller the divisor is as a percentage. So that's what we're going to do. So down here, we're going to go ahead and say that total resources equals mathf.square root total resources. And then we're going to just go and divide everything key. So here's the problem. I don't know whether this works. It might barf. Let's find out. You gonna barf? Yeah. So you can't actually do this because of nonsense. And this is actually the biggest weakness I see, with these resources. As far as I know, there's no way to do a for int with this setup. It's really, really obnoxious, and it's the biggest weakness of dictionaries. And there's got to be a way around it, and I just don't happen to know it, because it's really stupid. But we'll go ahead and just create a list of strings, or even just a key count, resources dot. So there's a count here, and there's a keys collection. I could probably try and get the keys collection as a separate thing. You think that would work? Let's see if that barfs. Well, it doesn't barf. The question is whether or not I can do a for each on that. For each string key in keys. And then we'll go ahead and say resources key divided by equals total resources. You gonna say that's okay, or are you gonna barf? Okay, so that works. It's a little bit silly though, because this is a very, very strange way to specify an array of strings. Well, I wonder whether I could have just made it an array of strings and it would have come back okay. Don't know. Don't know what a key collection is exactly, but that should end up reducing our resources to the correct amount. There we are. So now what we need to do is there's a couple more things that we're going to need to calculate out. And these are going to be based on the location and type of the planet. One of the things I didn't check here, though, is I forgot to check and see if we are glowing. So right now we are getting past color, but we're not getting past an emission. So we're going to go ahead and pass in an emission value. And then we're going to say if emission is greater than 0, resource equals fire. We can fix all that later if we have different kinds of resources. But you can see that we don't actually pass mark color, the emission, anywhere where we try and call it. Here it is. So we need to actually pass it the emission. And to do that, we're going to pass it the metallicity pixels index.b. Because that is the volume of our emission. The actual emission pixels that we've got are randomized slightly. So it's much easier to just pull it from the core values. So that will work just fine, and that should allow us to land on fire planets and stuff like that. So the other things we're going to need to know are where in the how much sunlight is hitting the planet, and so on and so forth. So to do that stuff, we're going to eventually need to have a concept of a solar system rather than just random free-floating planets. And we're not probably going to do that today. Well, maybe we can. Let's go ahead and do it today. Why not? Let's do it right now. So to have this work, we're going to need to create a sun. So create empty, and we'll call it the sun. We're going to need to have a sun script. There we go. So we're also going to need to have a particle system attached to the sun. To be honest, we're going to go ahead and attach it inside the sun so that we can have a variety of visuals that we can turn on and off, or maybe even pick randomly between some prefabs or something. But for now, this should work. We just need to have it as a particle system rather than a game object. I mean, they are game objects, but it's easier to just tell it to create a particle system. So the particle system that we're going to want to have is going to have a spherical emission, and we're not going to want to move any. And that's the basis of a sun, but obviously it needs a little bit more work, so we're going to continue to work on it. One of the things that would be nice is if instead of, well, so there are a lot of ways you can try and make this more interesting. And we can pick and choose any of them. But one of the core issues we've got is that it's quite a small set of objects. If we just increase it to, this, you can see that it's now super, super large and bright. If we change this over to, say, yellow, it looks pretty bad here in the scene view. But if we were going to look at it from the planet view, we'd hide this Earth-like for a second, and we take a look at the main camera here. We turn the main camera on. You can see how it blinds us in this view, but over here in the game view, what we end up with is a blazed out white background. So that's not exactly what we want, but it's just to show you that what we actually see here is not the same as what we get in the final calculation. I think what we're going to want to do is have a much, much smaller sun that's just big enough to cause the pop-ups to be at a slightly different position rather than popping up, unnoticeably on other sides of the sun. Then we can also do a color over lifetime where we just bring the alpha in and then out. And we'll also tell it to pre-warm so that it doesn't pop in strangely. And then if we turn on the main camera again, we'll be able to see it a little bit more clearly. And you can sort of see how that's going to look. So here is the core sun-fire element. And that's obviously not the only particle system we need, because we're going to need to have it look like a sun. Now, it's fine if it blinds us a little bit, but we still want it to have noticeable sun-like features. So in order to do that, we're going to create another particle system. And this one is going to specialize in creating the surface effects that we're going to need. So to do that, we're going to still need to have it emit from the sphere. And our start speed is going to be 0 again. But one of the more important things, our start size is going to be like 0.1. One of the more important things we're going to be doing here is that we're not going to be using the default particle material. We're going to be using a material that suits our needs a little bit better. So we're going to call this the sunspot material. There it is. And this sunspot material is going to be using the particle system here, but instead of being additive, it's going to either be multiply or alpha blended. I haven't really decided yet. And then we're going to pick any given blob. There it is. And that should be okay. Maybe. Let's find out. We'll go down to the particle system here, and we'll tell it to use that material instead. And if we, Luis Eldorado and Zesh both come by. Hello, I thought that nobody was here. Sorry that I didn't notice you stepping in. Luis says it's the first time he's seen me creating a game object. I do it rather frequently, but you might not be looking at the screen at that exact moment because it's a pretty quick little thing. So right now what we've got is a white ball. If we reduce this down to something that's orange or red, we should be able to see it, but we can't. That's interesting. Maybe particles.multiply is not right, and it should be particles.alpha blend. It may also be that it's the camera interfering. It looks like it might be the camera interfering. Okay. So the camera is really aggressively pursuing this incredibly bright light. So what we're going to do here is we're going to turn on the main camera and take a look, and we're going to reduce the light until we can see the particles that were in the background there. Okay, so as you can see, even the particles in the background are extremely bright. That's probably a good color. And then down here what we'll do is we will actively make these dark. That's interesting. They don't even show up. Okay. There we go. Now we're getting somewhere. So what we're going to want to have these do is move slowly over the sun. So the first thing we're going to want to do is have that alpha come in. So we're turn on color by lifetime and bring that alpha in. And you can see that that's made them quite faint. Oh, well, we've got a lot of options. We can go ahead and increase their rate over time or their size. And you can see that that goes very, very fast, but it's the right kind of idea. So what we can do is we can just increase their lifetime by quite a few orders of magnitude. Now, the problem with increasing their lifetime by so many orders of magnitude is that the rate over time gets all screwed up. There we are. So there's a lot of things we can do with this. I can bring it down to like 1, and that'll just give us these evolving dark blotches. And to be honest, you know, for 10 minutes work or 5 minutes work, this kind of sun is fine. We are going to want to change the size of our sphere a little bit, just because right now it is never hitting the edges. But I've just now reduced the thickness, and now it should hit the edges more often. But now I can't see it. Okay, so let's increase this. Let's turn off the camera so we can see what's going on. Okay, so this is obviously wrong. Hold on. So if we take a look at what we're actually seeing here, this is correct. But for some reason, it's not showing up anymore. So if we turn this on and we take a look at the game here, it may simply be that our sun is overwhelming it again. If I were to bring this down even further. Yeah, something like that. Now, there are a lot of other options for how to make these suns look good. This is just the fastest thing I can do, and it's a game jam, so whatever, right? I'm going to go ahead and bring this duration up to 60. And then what we're going to do is we're going to bring the lifetime up to 60 as well. And we're going to bring the rate over time down to 0.1. Because basically we want these to be things that really take a long time to evolve. Yeah, like that. Now the other thing we can do is we can create a sub-emitter. If we take a look down into the sub-emitter category, we can give it a new particle system that it emits. So what we're going to do is we're going to create another particle system. Boom. And we're going to use the same basic setup. So this is going to be a start speed of 0 or maybe 1. And we're going to go ahead and lower the start size. That's an interesting... and we're going to want to have the emission shape be... I don't even know whether this will work or not. We're going to have to find out. So this is going to be emitting 0. I haven't used a sub-emitter in a long time. We're going to find out whether I remember how to do it. So in theory, this should now emit little points of white light. But I don't see that happening. Let's go ahead and take a look in our scene view. So I think what's going on here is that this sub-emitter isn't emitting because we haven't told it to, but I'm not sure exactly how sub-emitters work. So what we're going to do is we're going to set it with a burst at, oh, there we go, at time 0 of 2. 2 to 3. Let's raise this up so we can just see it happening here. All right, so you can see what we're trying to get is something that doesn't look like this, but something that acts like this. Just so that we have something, you know, to be useful here. And what we're going to do is we're going to turn on trails. We obviously don't need the null particle for the trails. We'll go ahead and turn that onto our same sunspot material. And this can also be, that can be particle, I don't really care. But the whole point is that these shouldn't move very fast. So like 0.1. And their start color can be this kind of muddy brown. And their start lifetime can be 20. Now, the problem is that they're currently moving out, and I want them to move in. So if I were to change their start speed to -1, would that work? No. You know what? Let's not do it. It's just taking up time, and I don't want to spend the time doing it. So we'll turn off the sub-emitter, and we'll rack that rate over time back down to something feasible. And there we've got our sun. It's piecemeal, but it works. So the sun will be able to spawn a number of planets. And that's the basic idea here. We need to have a method of creating planets. Oh good, they've turned the volume up, just in case you couldn't hear it before. Now it's shaking my floor. He's got such bad taste in music, it's amazing. So what we're going to do is, we need to create one more kind of planet before we can do this. Sorry. So the planet we're going to create is going to be a gas giant, because we don't have one right now. So we're just going to duplicate one of these planets and then move it a little bit. All right, like this, for example. And then what we're going to want to do is make this into a gas giant. So the gas giant is just going to be a set of fun colors. So that shouldn't be too hard. Well, let's go ahead and find out. So the thing we're going to use most is going to be a function called I forget what it's called. It's called the polar purlin. That's what I called it. And the thing I like about the polar purlin is that when you use it, it gives you a a vertical base for what we're trying to do. Let's turn on tint by height for a second so that we can tell what's going on. Now the problem is that our scale is really, really low. So if I were to increase that scale, what happened? There we are. And then hit sample, randomize, and then sample. So right now I've got it on its side. The whole planet is sideways, so we'll just go ahead and rotate the whole planet so it's not sideways anymore. But you can see how there is a black beam in the middle, and then there's blue on the top and on the bottom. By repeating this at various grades, we can figure out exactly what sort of splotches we can put in. So by going down here into the noise map, we can change the exact noise map to create a different cutoff point for our colors. See? So this is a very top portion element. And the more we increase the scale, the more we'll get a feeling of it being like clouds, see? So doing this, we can create a couple of these and just change the offset and the color that they employ, and it should work out fine. So in order to do that, we're going to use a trick where we use a different channel. So we're going to just grab height, I'm going to change it to red, and then here we're going to apply this to red by adding it in. And then we're going to, actually we don't even need to do that. We can just go ahead and have it be override and then remove this. And that would mean that it should still work. Because override means that zeros will be zeros. And then at the bottom what we'll do is we will create a noise, a biome. And the biome can be any color we want. So we can pick and choose. Let's go ahead and take a look at a picture of Jupiter, just so that we get a basic idea for how we want this to look. So we don't want to pick colors that are too vibrant, but oranges are a good start. So we'll go ahead and start with an orange color. And there's also the option of here, we could put something where it dyes it a random color instead of one specific color. So why don't we go ahead and create a new biome element here. We're going to call this a complex biome and pull that up. This is going to descend from the basic biome, with the difference being that the complex biome is going to have a set of colors, and it's going to use a noise element. Maybe. Haven't decided yet. No, it's just come with a set of colors, that's all. So color 32 array, possible colors. And then what we're going to need to do is pull up the basic biome so I can remember how it's programmed. And you can see how this has a biome color. We're going to override the randomization function in here. And what we're going to do is we're going to say that possible color, that colors, biome color equals possible colors random.range 0, possible colors dot length -1. No, wait, because it's already exclusive. See, it says inclusive, but I think it's exclusive. Okay, so the integer is exclusive. That's fine then. There we go. And that way we can give it a set of colors, and we can just randomly sort between them. That'll work pretty well. So rather than the basic biome, we'll remove that, and we're going to give it a complex biome. And we are going to just select some random colors that Jupiter has. And that's going to be some oranges, some yellows, some whites. Let's put in the white first. And then we'll go ahead and give it some reds. And some purpley reds. And some purples. And some oranges. And some pinks. Some golds. Some really, really orange, vibrant orange stuff, just because why not? And lastly, we'll go ahead and give it a blue. Just one faint blue. So this purple is not very different from the blue, but that should be okay. And here what we'll do is we'll apply it to red, and we'll apply it to anything that's over 0. And that will allow us to create whatever biome we would like out of this. And if we go down to the gas giant and we hit randomize, you can see that every time we hit randomize, we get a slightly different band of colors. See? So just by duplicating this foundation and changing the noise map here, we can create ourselves a nice band of colors. So the first band of colors we're going to want is going to be the most aggressive. So for that, hold on. So for the first one, we're going to want to be the most aggressive. So for that, we're going to go ahead and pick the most aggressive of our systems. And here we're going to go ahead and be a little less aggressive, like. And then here we'll be a little less aggressive. And then here we'll be just a touch less aggressive. And then here we're gonna go ahead and make it there. And now if we randomize this, shabloom. Okay, so that doesn't seem to have worked very well. That's interesting. I mean, it worked a little bit, but not as much as I wanted. I think the problem is that the edges on this aren't sharp enough. So what we're going to do is here, we're going to go ahead and sharpen these edges, because these ones that are near the equator are the most aggressive. They have the softest curve, so they need to have the most aggressive interior curve or internal curve. So the song that he's listening to, as far as I can tell, the lyrics are, whoa, 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 whoa. So I honestly can't say if it's a Spanish language song or not. All right, there, that's better. It's still not a lot better, though, because look at how non-distinct that is. We're going to want the default color for the gas giant to be something memorable. We'll go ahead for a bright purple. I think that what we're going to need to do is this guy, we're actually going to invert it like this. And then down here what we'll do is for the applied height, that's still going to be the same. So, right, let's go ahead and try that out. All right, that's a little bit better. So you can see that there is this weird band of orange, and then there's some purple. That band of orange is our first foundational element. The problem is that it's not sharp. I want it to be super, super sharp. And I think that the way we're going to get that is by changing this to this. And we'll just go ahead and do that for all of them. At least for the ones in the middle. The ones at the top seem fine. There we go. Now we're getting somewhere. This initial foundation, though, it's a little bit too aggressive, so we're going to... Yeah, that's the one. I'm going to go ahead and pull this down. I don't know whether or not you can hear that, but yes, you're right. That's exactly what it sounds like. All right, so now we've got ourselves a very, very basic gas giant. The only thing that I don't like about this is that the middle band is not really very good. What I think I'm going to do is I'm going to scribble all over the planet between the first band and the second band. So to do that, we're just going to put something here. We're going to call it scribbles. We're going to go ahead and grab one of these complex biomes because we're going to use a complex biome here. But the difference between this and the other one is that we are going to just create random complex noise. So when we take a look at this, I'm going to red channel again. We can create just scribbles, and we're going to just create, yay, like this. And then we'll just take a quick little look at this. So you can see that what I'm aiming for is scribbles that are dense enough to make the inside of this planet look interesting. Yeah, like that. That's fine. So with that in mind, we can then apply the color, random color to them, and we'll end up with scribbles. But you can see this gold. This gold. So that gold is fine. And this, okay, so it just happened to choose the same color for both. Again? Wait, do these always... No, they choose differently. Huh. Why? Is it just incredibly bad luck that I got the same color twice? Okay, I guess it was. But the idea here is that we're trying to get ourselves some texture. Now, I'm not going to spend a lot of time on this gas giant. It is good enough as it is. Just as a gas giant, we need it to have the ability to have moons. And that's probably where you're going to get most of your effort. So the planet currently does not have the ability to say whether or not it is landable or not. So we're going to go ahead and add that bool. We're going to not even add it as a bool. We're going to add it as an enum. Public enum planet type. We're going to go ahead and say it is a gas giant. Moon. Earth-like or hot. And then we'll make that the top thing here. Public, planet type, planet type. And we're only going to allow you to click on the ones that aren't gas giants. If it's a gas giant and you click on a gas giant, it's just going to laugh at you. No, it's all going to laugh at you. So we'll add in a collider. And that means we will be able to click on this planet, but we're going to have a feature which, when you click on a gas giant, it'll say, hey, nobody lives on gas giants. Right? So the other thing we're going to need to do is we're going to have the planet have some ability to understand that it's part of a greater system. So the sun's going to create a descendant set of planets, and then the planets might have their own descendants. So to do that, what we need to have is either the planet has to have an underlying list of planets that are subordinate to it, or we need to just have a method of spawning additional planets that we can attach that's separate. That's a better way to do it, so we're going to go ahead and do it that way. We're going to call this the planet spawner. And we're going to just drop this on the sun for now. Boom. We're going to also drop it on the gas giant and stuff later, but just for now, we'll drop this into prefabs. Boom. The sun has this planet spawner. The planet spawner is going to be able to spawn a variety of planets at various distances. So we're going to have a public float size factor. Tooltip. Multiply standard possibilities by this. So if the size factor is smaller, you'll have fewer moons or planets or whatever, and if it's larger, you'll have more and they'll be bigger. So for that, we're going to go ahead and create a list of planets. Now we're going to have this tooltip lower planets smaller first. So we should have like the moons as planet 0 and then they increase. And basically what we're going to want to have is an animation curve telling us the potential for how, well, if we do that, we're going to have problems. Let's use the size factor for multiply standard ranges by this. And then we'll have a public int min planets equals 1 and public int max planets equals, I don't know, 7, whatever. We can adjust them later as we see fit. So what we're going to need to do is when we do this, we're going to want to just quickly figure out all of the planets and their ranges. Now keep in mind that the planet sizes are hard-coded to be at different scales. So if you're at a scale of 0.5, 0.5, 0.5, then that means that you are being displayed in a lower resolution. So a gas giant, which is at 111 scale, will actually end up taking up a tremendous amount of RAM, even though you can't click on it. So what we actually want to do is have all of these planets scaled to the same size. And then what we'll do is we'll represent their type just by their visual. So we won't have, when we spawn these planets in, they're all going to be like 0.1, 0.1, 0.1, even the central planet. But we are going to want to make it at least a little bit different. So the gas giant might be like 0.2, 0.2, 0.2 or something. Talking to myself to try and figure it out. So here in start, we're going to go ahead and say spawn. And then we'll have a public void spawn. That's not spawn, that's spawn. And this will have a menu item. And what this will do is this will just add the planets into the mix. So int num equals random.range min planets max planets. And then we'll do float range equals 1. We'll actually go ahead and say float our scale equals transform.localscale.x. And then we'll set this to our scale times 3. And then we'll go ahead and do for int a equals 0. Well, just while num is greater than 0, num plus plus, num minus minus, yeah. And we'll just go ahead and start to spawn in the planets. And to do that, we're going to grab a random planet. There we are. That'll grab a completely random planet. We're going to end up weighting this. So let's go ahead and put in the weighting value right now. Int max range equals 0. Max option, we'll call it, not max range, because we're using range for something else. And here we'll say if max option is less than planet options.length, max option plus plus. There we are. That way we'll be able to do this where it will definitely get the lowest grade stuff for the first couple of instances and will steadily increase. Now, once we have the planet, we need to instantiate the planet. So we're going to go ahead and say planet equals planet.instantiate, and we'll pass it the planet, and then we're also going to set it up as being inside of this object. And we can give it a position and a rotation as well. So we got the world position stays. Okay, so in order to do that, we have to have it be position, rotation, then parent. That's fine. So our position and a rotation, vector 3, pause, and our rotation is just going to be quaternion. So except for it's actually not. This is a local rotation, meaning that it's relative to the. I think it's local. If it's not local, I'll make it local later. But it's going to be the same rotation as the master parent, the parent option. And the position, we're going to start off the position as being equal to a new vector 3 of range 0, 0. And then we're going to rotate it by a random amount, right? So let's do that later. For now, that's fine. And then down here, we'll say range times equals 1.5f. That should work. Or we can even say just range plus equals our scale. Then down here we're going to say planet dot transform dot local scale equals vector 3.1 times our scale divided by 2, so times 0.5f. That way it's, well, half is probably too small. We'll see. We'll see soon enough. So that should all work just fine. I think. Grind, grind, grind. There we are. So we've got a couple of planets that we can choose to spawn. Let's go ahead and delete all of the planets that we have in our system and put the planets into this list of planet options. So if we look at the prefabs, we've got a couple of planets that we have the ability to add. And we're going to want to add them in order from most closest to the sun out to least sun-like, right? So we'll go ahead and do Earth-like, and then Moon-like, and then the gas giant. There we go. And if we hit play, it should spawn them in. I don't have a camera running, but you can see that it did. We got several hot planets and other stuff going on here. Now, for some reason, some of these aren't rendering quite right, but that's fine. We'll deal with that. Now, what you can see here is that these are all at 0.5 scale, but that means that they are not far enough away from each other to actually work out. So we're going to go ahead and make it so that the range increases by r scale times 2, just so that we don't have that problem. We're also going to just fix up these planets so that they all have the correct starting value, since some of them are set to having to being marked done, and that's just wrong. Did I just change one over to finished because I'm an idiot? I did. There we are. The other thing we're going to want to do is this sun is at 111. We're going to change it to 0.5, 0.5, 0.5, or maybe even 0.3, 0.3, 0.3. Hold on. 0.3 times 0.3 times 0.3. Yeah, that's actually 0.02. What are the limits I put in? Under the planets, when we get the scale, we get whatever our scale is, local scale.magnitude, and it changes over into local scale.x. Because that way it will be easier for me to personally figure out what the heck's going on, and I don't have to worry about multiplying crap out in my head. So if we change this to 0.5, 0.5, 0.5, then all of the planets will spawn in at 0.25, and that means that they will be at the lowest possible resolution, which means they'll render really, really fast. So in this case, we got the minimum value of 1. Now we're going to turn on the main camera here, and I'm just going to move it until I think that it's going to be able to see all of the planets. Boom. And you can see that what we've got here is a variety of planets spawning in, all of which are on their side. Now that's because this is not rotated, but if we were to spin this and then hit play, they're still on their side. Okay, so that means that they do not inherit the rotation from their parent. So we're going to want to have that take a bet. We're going to want that's something we're going to want to have happen. It's going to inherit from its parent. So rather than quaternion.identity, we're going to want it to be transform.rotation. And then here we're going to want to do transform.position plus new vector 3 range. Yeah, something like that. And that should allow us to get the proper offsets, right? The last thing we want to do is we actually do want to have a secondary sun, and for that we're going to go ahead and save the sun as a duplicate. Let's go ahead and duplicate the sun. We're going to call this a brown dwarf. And it's going to have some slightly different values, so we'll just modify it here. No gas giants for the brown dwarf. And we're going to want to have it look a little bit different. So let's hide this sun while we work on the brown dwarf. The brown dwarf's particle system needs to be redder and quieter, like this. That's fine. So then we're going to save that as a new kind of planet, and we're going to allow the sun to spawn those in as well. No? You don't like that? Oh, because it's not a planet. Right. So we actually want these planet options to be game objects rather than planets. How annoying. Okay. Well, that's fine. We'll go ahead and call these game objects. And down here, we won't do the planet. We'll do the game object. We're not doing anything planet-specific during the spawn cycle, so it doesn't matter. The question is, will this survive? No, of course not. Okay, so we're going to just go ahead and drop those back in. Hot planet, moon-like, and then Earth-like. And the sun, same deal, but it's going to be hot planet, Earth-like, moon-like, gas giant, brown dwarf. Right, like that. Okay, so you can see that this gave us exactly one planet. It's just got a hot dwarf. And even from here, I can click on it, and it will fill in the scenario. So the only problem is it says invalid operation exception out of sync. So it looks like the dictionary we're using can get out of sync somehow. The dictionary in the city. I'm not sure how that's even possible. We'll deal with that later. But you can see that now we've got several hot planets. Now the problem with these hot planets is that they are not randomized. So what we're going to do is we're going to go over into the planet section, and in start, when we check and see whether or not we're trying to render something, if we're trying to render it, we're going to go ahead and hit randomize rather than just render. I believe that randomize also renders, so that should end up with a bunch of different elements. You can see that these are both just hot planets. There's not really a setup for anything other than hot planets until you get much later in. There we are. So this is 3 hot planets. But you can see that at least the 3 hot planets are, in fact, quite different. All right, so now we've got hot planets and a moon-like and all sorts of stuff. So if we were to grab our camera and move it along, shoop, 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 you can see that we can see a bunch of planets. Now, there's no difference in their sizes, even though they are, in fact, different-sized planets, and that's because this is not to scale. It's just a stupid little game. I'm not going to worry about it too much. The problem is that the gas giant didn't spawn any additional planets, and the reason is I forgot to add it in on the gas giant. After all that work to get the gas giant to actually work, I forgot to add in a planet spawner. And the planet spawner is just going to spawn moons. So let's go ahead and increase the sun's output just so that we can make sure that we don't have to wait as long for a gas giant. Wow, we got a lot of Earth-likes. No gas giants, though. Beep, beep, beep. That's an interesting one. It may be that what I want to do is also increase the minimums, at least off of 0. Let's go ahead and do that. No, only if there is... So, hold on. Down here in our planet spawner, we're going to go ahead and say game object planet. So, int min_opt equals 0. We'll make this a min option. There we go. And then what we'll do is down here, we're going to go ahead and say max option ++. And if max option is greater than or equal to 2, then min option equals 1. That way we won't get hot planets out in the middle of nowhere. It's like physics. All right, so now we got a bunch of stuff. Hot planets, Earth-likes, and moon-likes. No gas giants. The other problem is that these are all coming out as medium grade. If we take a look at the size of the textures, these are all 256 texture, which means that the planet is not giving us the correct LOD. There it is. So greater than or equal to, just make this greater than. There. See, now that's a much, much smaller resolution, but it's sufficient to show you what's going on. All right. Still got no gas giants. This is really interesting. I didn't expect to have such a hard time getting a gas giant. There it is. Finally, a gas giant. So we're going to just skate on over there and see the gas giant. Okay, so you can see how the gas giant has some moons attached to it. The problem is that those moons are at this ridiculous distance, and that's not what I wanted. I wanted them to be a lot closer than that. So presumably, that's a little bit odd, but presumably we got like so those are the correct size, but the offset ended up being considerable. Why did it end up as 6? It should have ended up as like... Hold on. Let's take a look and see what happened here, because our spawning is obviously not working right. Range equals our scale times 3. So in that case, our scale would have been 0.25, so range should have been 0.75, not 6. So when we go here, what we should have seen is transform.position plus new vector 3. Okay, so hold on. Is the problem here just that I need to make it so that it's not in world? No, there's no option to set a world position. Well, what we'll do is we'll go ahead and set this up as just inside of our object with false, and that'll set it up inside of this planet, inside of the spawning planet. And then what we'll do is we'll say planet.set planet.transform.set position and rotation. And we'll go ahead and set the position up. Is there a set local position and rotation? Nope. Is there a version of this for? Nope. Okay. So those are world. I guess we'll just do it without that. It doesn't really matter. It doesn't have to be fast. Local position equals pause. And then we'll say planet.transform.local rotation equals quaternion.identity. And planet.transform.local scale is going to just have to equal 0.5. Now the problem is that this actually gets assigned as local scale, which is why it's just going to be 0.5. Because if it's otherwise, it'll end up being half of half of half. Now the problem is that our planet takes local scale into account when calculating out the LOD. So what we need to do is actually get the global scale instead of the local scale. And so to do that, we're going to change this from global scale or local scale to lossy scale. There could be a lot of things wrong with this. We're about to find out. So you can see that the first problem we're going to have is that now that we've switched it over to being all in local space, the planets are bunched up very, very close to the spawner. And that's especially true of the sun. So with the planet spawner, we're going to go ahead and have a public vector3 start offset equals vector3 dot right. And so down here in our range, I'm going to go have a start offset plus that. That way we can try and avoid spawning it directly into our sun. So that's better. Now the range increases aren't quite enough. So rather than being range times equals 2, we're going to go ahead and make that times equals 3. There we go. We got a gas giant, so let's go take a look. So here's the big question. Do the gas giant's moons go up or backwards or what? Because they could do anything. That didn't do anything. That's a directional light, that's why. All right, so I don't see any moons. There's one moon, and it is... Turn off this camera. It is inside the planet and going the wrong direction, as you can see. So when I take a look at the planet, the gas giant here, hold on, there's actually... Oh, I see. It's in the right spot. It's just that there's another planet in the way. So what we're going to need to do is come up with a couple of different variations here. So we're going to have start offset, and we're going to have a public vector3 per range offset. Size factor can go away. Don't need it. And so here we're going to go ahead and say that this doesn't exist. Float range doesn't exist. Start offset. So vector3 offset equals start offset. And then here what we'll do is we will say that start offset. And here we'll say start offset plus equals per range offset. Perfect. That way we'll be able to get these properly set up. But the one thing we need in addition to that is to set up our various other planets to have the correct offsets. And to do that, we're going to change them over to using Y rather than X. All right, so we do have a gas giant. Let's cruise on over and take a look. Okay, so gas giant, gas giant. You have 4 moons, and then none of them are in the right spot because Y and Z are not the same thing. All right, so if we take a look here, This is what it currently looks like. So what we need to do is alter these values until they make sense for our needs. And that includes all of these, because we've screwed up everybody's defaults. So the sun has to have a starting offset of 2 and a per range offset of 2. The gas giant has to have a 2 and a 0 and a 1. And the brown dwarf presumably needs the same setup. All right, so let's go ahead and change the sun's offset even more. That's a little bit better. So now if we take a look, we can scoot along. And you can see that what happens is we now have moons below our gas giant. So the last thing that we're going to need to do before we can do anything serious is we're going to have to change the lighting setup because this directional light is no good. So instead what we're going to need to do is put a light inside of our sun. We'll go ahead and put a point light in. I could do a spotlight or an area light or even a directional light. Okay, we'll do a directional light because that's what makes the most sense. So we'll just hide this main camera, take this directional light, and point it out in the direction that the places are going to spawn. Now, what we're going to need to do is with the brown dwarf, we're going to need to put in a point light. Point light. And that seems about right. We'll make it intensity 0.5. And that should work. Now, did I forget to, hold on, did I forget to turn off, good, no shadows. Because there shouldn't be any shadows. All the planets are lined up silly, so it should be no shadows on them. And the lights are way too bright. I forgot that I had the intensity down at 0.25. So we're going to need that intensity lowered everywhere. That's better. So now what we've got is a set of planets where the light is actually coming from our buddy the sun. And as we cast along, you can see that we can slowly see the backside of these planets rather than the front because we're not using orthographic projection. And that's fine. Now here you can see a whole host of planets. So the basic idea is that we're going to have some kind of technique for zooming in on a chosen planet. And so what we're going to do is we are actually going to have it so that when you zoom in on a planet, it's going to have to move and then change scale. And so to do that, what we're going to want to do is have either an animation or a faked animation. Because what's going to happen is I'm going to click on the planet, and the other planets are all going to drop away, whereas we are going to rise and go up. And that could just be us going up. It doesn't have to be everything else dropping away. But to do that, we're going to need to put in an animator on the planet and an animation that goes up and then increases the scale. And I think that's probably easier than doing it algorithmically. We'll go ahead and give it a shot. So we're going to drop an Earth-like into here, just so that we've got something to work with. Hide the camera so that we can see what we're doing. Going to go ahead and leave it a white block. So that's going to be our Earth-like planet for the moment. Now, one of the issues I have is that this white block appears to not be quite right. That's odd. The mesh collider should be... I can't see it. I think it's okay, but I saw something weird, like a sphere inside of the sphere for a second, and that was worrying me. So what we're going to need to do is add in an animator. And we're going to need to have a controller for that. Planet animator. And we're just going to go ahead and drop it onto that stack. And now what we're going to need to do is do some animations for it. And there's a couple of animations, but the one we're going to start with is the one where it goes up. Now, the problem I've got with this is I'm not entirely sure that this will work the way I need it to, because I needed to change the Y without changing the X, and I'm not actually sure that I can do that. I guess I need an animations directory. So here's our zoom in on planet, and we're going to try to make it work. And the way we're going to have it work is it's going to take a full second to zoom in, and the reason for that is because the scale will need it to recalculate, right? So if I change the y-axis to, 4, in theory that works. In practice, it's going to end up zeroing out the x-axis, which I don't need, and I can't make it do just 1. How obnoxious. So that leaves us with no real ability to do the animation unless I can somehow create a different method. I could wrap every planet in an arbitrary game object, but that seems really dumb. How obnoxious. So my options at this point are to either do it algorithmically or to wrap every planet in a game object whose only purpose is to hold its position while it animates. I mean, I guess I can do that. It's dumb, but it's not hard. So I guess that's the way we'll do it. So what we're going to want to do is change. I think how we're going to do it is we are going to make it so that it becomes ensconced just by the planet slot here, just by the sun itself. The sun itself will figure out how to do this stuff. So to do that, we're going to drop here planet slot, and it's just an empty object. It means nothing. It's got nothing in it. It doesn't do anything. Let's set it up at 0, 0, 0. And what we're going to need to do is have all of our planet spawners have the ability to have a planet slot. Now, I could make them generate just an empty game object. That's not hard, but there may be something I want to do, have a more complicated setup, so it's a little bit better to do it like this. So first we're going to go ahead and game object slot equals game object dot instantiate, what did I call it? Planet slot object. Transform and false. And then down here, instead of being inside of us, we're going to have it be inside of the slot. And then all of this other stuff is going to be applied to, not all of it, sorry. The local position is going to be applied to the slot. The planet's local position will be something that is affected almost entirely by the animator, so we're not going to want to have that be a thing. So this should, in theory, work. The only problem is that now I've got to set it up so that every single one of the planets we've created has a planet slot plugged in. Offset's never used? Oh, yeah, this should actually all be offset. That'll be a nasty surprise if I had left that in, because that would mean that every time it gets run, it gets further and further out. Drop stuff. All right, so there we go. All I have to do now is add in these values into every single spawning object. There's only 3, so that's not too bad. Planet slot. Planet slot. Planet slot. But to tell you the truth, we should probably add these to the Earth-likes as well. Let's go ahead and copy this. Go down to the Earth-likes and paste it in. Don't run. God damn it. There we are. It's going to be 0 to 2. All right, so that should now work a little bit better. We're going to need to do the animation that we were trying to do before. So basically what we're going to want to have it do is go up to the top here, maybe even higher than that. Can I go to 5? 5, yeah. So, and then we're also going to want to have it scale up to 1, 1, 1. The problem is that this scale might be inside of another object. And if that's the case, then this won't actually scale it up very much. It won't actually scale it up enough to matter. So we may have to have the scaling be a separate function. For now, let's go ahead and just see whether the zoom in on planet works in the first place. So here's our animator, zoom in on planet. We're going to want that zoom in on planet to be a non-looping animation. So this is going to be zoom in, and we're also going to want to have a zoom out. There we are. And that's going to have a speed of -1. And that should be pretty straightforward. We're going to also need to have a don't do anything animation, which I guess we'll go ahead and record a new one. Nothing happens. So there's our nothing happens.anim. That's going to be our default. And then we're going to have a new set of triggers. So we'll zoom in, and that's just going to be make transition. Make transition. Nope. God damn it. So here we're going to go ahead and say if zoomed in is true, then move. And here we're going to say if zoomed in is false. And then here we're going to say if zoomed in is true. There. And that should allow us to zoom in on planets by clicking on them. And the way we're going to do that is we're going to go over into the click master. And then here when we click, we're going to check the P. And we're going to see whether or not we're zoomed in. So we're going to need to keep track of what planet we're zoomed in on. Public planet zoomed in on equals null. Down here we will say if P equals zoomed in on, then city.run. Else zoomed in on. So we're going to need to have a planet zoom setting. Just put it down here so we don't have to continue to code it. Public void set zoom bool zoom. Animator a equals get component animator a dot set bool zoom zoom. What's going on here? I don't know why that was red. So we'll just go ahead and say p dot zoom set zoom true. But we're also going to want to say if zoomed in on, then zoomed in on dot set zoom false. And then we'll say zoomed in on equals p, and then zoomed in on dot set zoom true. Now in theory, what that should do when we hit play, currently it's only on Earth likes. So our scale is never used. Oh, of course not. We've stopped using it. But that'll only work with Earth likes right now because Earth like is the only one we've got it assigned on. So what we're going to want to do is copy this and paste it into all of the different planets. So if we go down to the planets, the brown dwarf is an exception. We can't zoom in on the brown dwarf. Got the Earth like, it's already there. The gas giant we can't zoom in on either. The hot planet, we'll go ahead and paste it in. The moon like, we'll paste it in. And the planet slot, we don't need it. No cameras. All right, turn it on. Whoa, look at that. So we have a situation here. Interesting. What we've got is a fascinating situation. So we've got this hot planet here, and it's its own little thing. And then we got a hot planet here, and it's its own little thing. For some reason, the planet spots are overlapping. First off, let's go ahead and rename the planet slots after the planet. And what basic dumb mistake did I make to cause this? Because this is something special. So you can see that the planet slot here is 300. Planet slot here, 500. Then for the Earth-like, it says it's an offset of 700. But why is 700 500 with a little bit extra? What's going on there? Like, this should be 5, and then this should be offset. Okay, so hold on. The planet is at 000. Okay, and this planet is at... Okay, so the problem is that not all of the planets are in the same spot. So we're going to go ahead and hit comma. Instantiate in world space. True. Well, hold on. 3, 5, 7. Okay, so what the heck? These are still not anywhere near being in the right spot. Okay, so apparently it doesn't matter whether I pass true or false. It's going to instantiate however the hell it wants. Pass true when assigning a parent object to maintain the world position of the object. So it was false. But I did false before because I thought that's what I needed, and it didn't work. I guess the real thing to do is to just clear out all of the values in these planets so they can't possibly be in the wrong spot. That's kind of annoying and stupid and shouldn't be necessary. Take a look at the scene. All right, now we're back to having it make sense. So as you can see, we've got a bunch of planets with moons. If we turn on the camera, we should be able to click on them. So let's take a look here. If I click on this, parameter zoom does not exist. Did I spell something wrong? I bet I spelled something wrong. Zoomed in. Why did I name it zoomed in? Call it zoom. Wah! All right, so obviously it's misunderstood which direction I want it to zoom, but the basic idea is sound. So I could have it zoom up and then have the camera follow along or something similar. Let's go ahead and do that then. Right now it's zooming along the wrong axis. That's actually not too hard to fix. We'll just drop the Earth-like here, go over to the animation, pull up here, and you can see how it's changing Y. I think that we actually only need to change X. So we'll go ahead and clear out this and make it zoom in on the X axis instead. Oh, I didn't hit record. Record. Let's see whether that's the right direction. Now, I think that it still might be the wrong direction because I wasn't actually thinking very hard. It's probably Z that I need. Yeah, it's Z. Idiot. All right, so that should work. Let's try it out. Wah! So that went the wrong way. But it went precisely the wrong way, so I can fix that pretty easily. Just go over here and change this to -5. Now we're also going to want to follow that along. So here in Update for our ClickMaster, we're going to want to have the camera follow it along. Camera track. No. Public void camera track. If zoomed in on, then we're going to want to have our transformed look at zoomed in on .transform.position. And we're going to want to have our camera move a little bit. So vector3 ideal pause equals zoomed in on .transform.position plus vector3.forward times 3. I make that a minus. And then we'll go ahead and say transform dot position equals vector3.lerp transform.position ideal pause and time.delta time times 2. And a lot of people don't like that lerp. I like it. But you know, I'm not that concerned. Turn this on. So now if we click, rip. Now it can't see anything else. Click here. Those don't yet have a collider. So we'll drop our moonlight into the world here and we'll add in a collider. And then we'll apply that change and delete it. Let's go ahead and have that look at also get lerped. Well, never mind. It's not worth it. All right. I have been on here for a little while, and I am starting to get hungry and tired. So I think I'm going to stop. I'll probably do a little bit more work later tonight, but I'm not sure if I'm going to stream it. Anyway, thanks for stopping by, and I will see you later. Remember that this will be done this weekend. It's a jam, so I'm going to finish it, submit it, we'll be done. There's only a couple of pieces left, believe it or not. All we need to do is randomly generate solar systems, which we're halfway done with, have a couple of people, robots or whatever, aliens, commenting on the planets that you're settling, and allowing you to sell the planets. So that should all be fairly straightforward, and I will see all of you some other day. Where's the stop button?